Hello, hello, and good afternoon. My name is Wade Holmes, and I'm the head of security solution management within Google Cloud. And with me, I have Steve Meckl.
Hey everybody, I'm Steve Meckl. I'm the head of operations for Google's Autonomic Security Operations Solution.
And super excited to be here at MWise and to talk about how to design and secure the multi-cloud enterprise. So in this session today, first we're going to start out with a premise and wanted to get the audience feedback on this. So most enterprises are multi-provider today, but not truly multi-cloud. A true multi-cloud framework is critical to maximizing cloud services at scale. So show of hands, how many people agree with this statement? Or anyone disagrees that thinks majority of enterprises today are actually truly multi-cloud today? Because from a Google Cloud and Google perspective, this is what we have seen commonly as we look at enterprise organizations. Enterprises are adopting multi-cloud and multi-cloud programs because of multiple reasons, or driving towards this, whether it's trying to have the best of breeds from tooling perspective, avoiding lock-in, trying to reduce risk, which is an interesting one, which I'm going to dive into further. Or a lot of times it's not by design, but it's through merger and acquisition, and they end up having multiple cloud providers, but aren't truly driving towards or have a cohesive multi-cloud unified strategy. And so this is juxtaposed against this desire to actually reduce risk as an outcome of a multi-cloud, adopting multi-cloud. So how do you actually truly reduce risk? And most organizations will have a philosophy, we must be multi-cloud to be able to improve your risk posture. But if you don't truly have a cohesive multi-cloud strategy that looks at how you implement security and compliance controls consistently across different multiple providers, how are you truly reducing risk? So as organizations look at multi-cloud, this is an evolution of what we've seen over the past 25 years or so in industry. It started with multiple layers of abstraction in IT and IT processes and technology. First, it was virtual machines, and this is an area that is near and dear to my heart. Before I was with Google, I spent over a decade at VMware. So it was very much part of the movement where people were moving physical machines to virtual machines and re-architecting their data centers as part of virtual machines. But in the P2V movements that were happening, a lot of the same vulnerabilities, the same processes were being moved into those virtual environments. Now, don't get me wrong, there were some benefits that were put into place, things like microsegmentation and being able to segment environments more easily with some of the benefits, but it didn't necessarily change the software development lifecycle to truly be able to prevent vulnerabilities or detect vulnerabilities. Then the next wave, containers and containerization. And obviously this is an area that Google was a leader in and is a leader in, and helped to developing Kubernetes. And this is, once again, another layer of abstraction that's been developed and another opportunity to be able to embed security into organizations. But a lot of legacy processes, a lot of legacy technology still is left over. And this is not an easy process to implement across all the different deployment models within an organization. So when we look at organizations now adopting multi-cloud and looking at multi-cloud as a way to reduce their risk, there is another opportunity here we have to truly do this right, to truly shift left and truly put in the preventative controls in place as they adopt cloud, and also bake this into the software development lifecycle and to utilize tooling within the cloud. And this is what we're trying to achieve within Google as we provide prescriptive controls and prescriptive guidance as organizations adopt cloud. So quite simply, a unified multi-cloud design needs security baked in to be able to allow multi-cloud adoption to be a platform for organizations to be able to manage their risk, and not a area where they have to actually have to worry about the new risks that they're introducing. And we do believe that adopting cloud and the capabilities that are within cloud can enable an organization to reduce their risk in a more controlled and pragmatic way, but it requires a mindset and it requires proactive controls being put in place, and also being able to then take advantage of some of the detection response capabilities to be able to have a feedback loop to once again improve those proactive controls that get baked in the software development lifecycle. And these are some of the things that we're talking about today in this presentation. So, and why is this so critical now? I've said there's been multiple phases, multiple levels of abstraction and transformation that organizations have gone through, but things are more important than ever before and right now. And this is for multiple reasons. Obviously, our world is now more reliant on technology more than ever before. Adversaries are more sophisticated than ever. And it's not only nation state adversaries. We're seeing something that we call the nation state pivot, where adversaries now and the capabilities of adversaries are being democratized so that they're now able to expand attacks for profit with commercial models, with structures that are sometimes more organized than sophisticated corporations. This is juxtaposed against the lack of skilled workers that are able to defend organizations, and just the lack of the skill set within organizations to be able to scale incident detection and response. So this is critical for multiple reasons. And cyber risk is now a board level topic and has become the biggest risk for many organizations. Manage it effectively is imperative for organizations to drive forward with a digital transformation journey. And at Google Cloud, we're trying to put in place prescriptive guidance and frameworks that are able to help in this multi-cloud transformation in a secure manner. So this gets into something that, if you saw the keynote this morning, Phil Venables, our CISO, mentioned. We have a philosophy at Google Cloud called shared fate. So shared fate is our take on the shared responsibility model. I'm sure everyone here is familiar with the shared responsibility model as organizations adopt cloud and look at building software on the cloud or adopting cloud technology. And it's basically where a delineation line is drawn, or a typical shared responsibility model of what the cloud provider is responsible for from a controls perspective, from a security and compliance perspective, and what the customer is responsible for. And that line can differ depending on the technology that's adopted. The line's a bit lower if it's infrastructure as a service, or it's platform as a service, the cloud provider is responsible for a little more. If it's SaaS or serverless, then the cloud provider is responsible for more and the customer less. But this, combined with actually adopting multiple cloud providers, is quite complex, and we believe is not enough from just having a shared shared responsibility model that has a line of delineation. So at Google Cloud, we believe in a philosophy we call shared fate. And shared fate is being an active partner with our customers, with our consumers of our cloud and our technology, to be able to provide prescriptive guidance and controls and recommendations so that we're in it together with a customer as far as protecting their environment and enabling a secure environment. Some examples of this is part of what myself and Steve do in our solutions team. We're part of our security solution engineering within Google Cloud, where we create proactive and prescriptive solutions. And a solution from a Google Cloud perspective includes our platform capabilities, our SaaS capabilities. It can include additional blueprints and code and guidance. It can include services. So all of these are wrapped up in what we recommend to customers and want to be able to enable to be able to implement this shared fate model. And this is all based on our technologies that we've developed in Google Cloud that we want to be able to share with our customers. So that's going to talk a little bit about diving into one specific area. I'm sorry, actually, one other thing I did want to mention is in providing proactive controls, we've developed things such as our security and resilience framework. Our security resilience framework is a programmatic approach that maps across all of our solutions and is a tool that we utilize to be able to see where a customer is, understand where the capabilities are, understand where the cloud capabilities lie within Google Cloud, or our capabilities that span across clouds, and be able to provide a roadmap and based on maturity levels to guide a customer down their digital transformation and security transformation journey. So now I take a step, zoom in a little bit, and obviously from a Google Cloud adoption perspective, there's many different areas from a Google Cloud perspective. There's infrastructure modernization, there's data analytics, there's AI, ML. But when you look at application modernization and the chance to shift security left in the app modernization lifecycle, and looking at this from both a cloud adoption perspective and multi-cloud perspective, there are a number of things that an organization has to understand to be able to do this successfully. First, they have to understand what is their actual process for building and shipping software today. How are applications packaged? What type of repository is being utilized? What CI/CD tools and pipeline, and what's the pipeline process today? How are secrets being stored? What process is there for a dev to provide an early feedback loop? And this is something that Steve is going to dive into further, and how detection and response can help to enhance this. How is compliance being assessed? Are there service mesh technologies that are being utilized that can now allow this to be maintained operationally in a consistent manner? And what are the tools that are being utilized to be able to manage things once applications are being developed from a runtime perspective? So all these, first, you have to look at from a organizational perspective, understand where you are. As mentioned, we have our security resilience framework that we utilize to guide an organization down this path, and then understand where some of the capabilities are from a Google Cloud perspective. So this is a map of our baseline security foundation recommendation and processes for container and serverless within Google Cloud. So you can see there are 10 different areas here, and we kind of simplified this into a 10-step process. I mentioned we actually have this for both multiple different areas and multiple different cloud adoption journeys within Google Cloud, and this one's specific to container and serverless-based architecture. And first, there are a few things to note as from a cloud adoption journey perspective and a multi-cloud perspective in general. First, looking at identity. So many people say as you adopt cloud, identity is a new perimeter, and being able to understand how you federate identity, utilizing cloud capabilities, being able to integrate this in with what an organization already has on premises is critical in secure cloud adoption. And this includes identity to be able to manage the actual resources that are adopted within Google Cloud, and also from a development perspective, when organizations are building applications and being able to bake in multi-factor authentication into the application and web applications are being built. At Google Cloud, we have capabilities such as our Cloud Identity Platform, which allows for pre-built modules to make it easier for multi-factor authentication to be built into web apps as they're built. Then you look at things like log and log collection, which are making sure that you have consistent logging across the infrastructure. Looking at cloud security posture management capabilities across the board. Within Google Cloud, we have a service called Security Command Center Premium, which we recommend for every organization that is adopting Google Cloud as a default to be able to have the proper visibility from an event threat detection and container threat detection perspective for any workload that runs within Google Cloud. Then you look at our other capabilities such as key management, certificate authority services, networking, and these are all, there are a plethora of different capabilities and solutions and prescriptive guidance, and really all of those are going to be pretty common and default recommendations, whether you're adopting container and serverless-based architectures, whether it's lift and shift with infrastructure modernization, whether it's data analytics, AI/ML. These are all baseline capabilities that we would recommend as an organization is adopting cloud. But then when you get into actually the CI/CD pipeline, there are some unique capabilities that we have within Google Cloud that we recommend as an organization is looking at being able to protect against today's attack vectors and today's threats. So why is this critical as you look at the software development lifecycle today? So there are a number of different attack vectors that threat actors can utilize to compromise an organization. I mean, we've seen this, we saw this morning in the keynote, the discussions with Colonial Pipeline, the discussions with SolarWinds. And these are all examples of organizations that at the time were not able to attack against these vectors, such as being able to make sure there isn't compromised source code, making sure there isn't a modified source build within the source or build process, making sure that their packages and dependencies are secure. And then once things are actually deployed, being able to make sure that deploying an image that is safe and secure and making sure that there isn't anything from a runtime perspective that has been compromised. So we have a number of capabilities within Google Cloud that both built on the SALSA standard that ensures for a secure source build and package process, and then from a runtime perspective, be able to monitor things after the fact once you're in the QA test and production cycle. So this is all about being able to establish trust early on in the development process, be able to attest through standard policies across and collect attestations throughout the software development lifecycle, establishing trust through each part of the process. Then it's also about once you're able to attest software, if you failed at any of these points, you're able to verify trust, and if you're not able to have the attestation be passed, block the actual deployment of those software and software packages, and then maintaining trust from a runtime perspective, and maintaining this continuously through our policy and through policies that are holistic across environments. So as you look at this from a Google Cloud capability perspective, we have a number of capabilities that tie into this secure CI/CD pipeline, which include our artifact registry and artifact analysis. Being able to have a secure repository for checked in code that ties into the CI/CD pipeline and is able to analyze for dependencies and analyze for secure packages. We have our assured open source software service that actually provides signed by Google and SALSA verified packages that an organization can use to be able to assist in maintaining the security posture. Then we have unique capabilities such as binary authorization that will implement verification to make sure that this is trusted code, and if it isn't trusted code, will block this code from actually being deployed. And then within the actual infrastructure itself, we have capabilities such as container threat detection that will be able to maintain and scan for vulnerabilities in the runtime environment. So these are all foundational capabilities that we recommend as part of the software development lifecycle as the organization adopts cloud and moves their software development lifecycle into a cloud environment. And then to tie this together from a multi-cloud perspective, we have a managed platform called Anthos that is basically our way to be able to extend the Kubernetes runtime environment across clouds and be able to have consistent operational consistency as you build environments, as you have the secure CI/CD pipeline process that I mentioned, and being able to provide governance, consistent operations, and consistent security across different environments. So I touched on some of the preventative controls that we have within Google Cloud and our high-level process and approach. And now I'm going to hand it over to Steve, and he's going to talk a little bit about how detection and response ties into this process.
Thank you, Wade. My area of expertise is security operations. I've spent the bulk of the last 10 years, maybe 15, focused on large-scale monitoring, detection, and response operations, including running one of the largest commercial MSSPs on the planet for a while. And I've seen support for DNR support for a wide variety of security devices, on-prem applications, cloud services, and by far the most challenging thing to do detection and response on is custom applications, and it's gotten worse, not better, as people have migrated cloud native. Actually, cloud natives are probably better, but as we migrated applications from on-prem into the cloud, one thing that just isn't taken into account is how do you log from your application, or how do you design your application to support the mission of the SOC? We hear a lot. I've heard in a few panels and some discussions earlier about how security tends to get in the way of the agility of the organization. My day job is working on the Autonomic security operations solution for Google, including trying to make a shift in the industry towards a more agile methodology for SecOps. There was a full talk on this morning by my colleagues Iman Ghanizadeh and Anton Zhivakin. If you missed it, hopefully there's a way to get a replay. But this is sort of the core of it. I'll cover it in one slide just so you have some background on what we're trying to do. If you've talked to your SOC team, you probably hear a lot about the main mission of what they have to do, and it's really centered around these 4 pillars. You got to get visibility into what's going on in your enterprise. You got to leverage that visibility to build security analytics for real-time detection, threat investigations, threat hunting, and the like. You need to respond when a threat happens, whether that's in a manual or an automated fashion. And most importantly, you need to build in the hooks to have continuous feedback into what's going on in your program. I was lucky when I was leading teams to have Six Sigma experts and process excellence people on board that could build all this stuff, build metrics around our KPIs and our OKRs. I always had really solid capacity models. I knew how long it was taking us to detect things, how to respond. All that stuff is really important because that allows the SOC team to make strategic decisions on where you need to improve your program. And the idea here is not to just do these 4 things, but to tighten tighten the loop. So instead of doing a pen test every year and getting some feedback, run continuous security simulation in production so you always keep your security team on their toes. Recognize when new things, for visibility, recognize when something is attached to your network immediately as opposed to when you find out you have shadow IT during a breach and the like. And building the agility into the SecOps program so that it's continuous improvement. You're improving on your program across these 4 quadrants multiple times a day. And the best SOCs in the world are doing this. And what I want to talk about in this section is how do software developers design your application as you're moving into the cloud, especially if you have multiple cloud implementations, so that you can make the mission of the SOC team easier, right? Because if you make their job easier, they'll make your job easier. There's some lag here. Nope, I just didn't press it right. The first is build visibility into your applications. As I said earlier, custom applications are the hardest thing to do detection and response on. Most developers do some sort of logging, but logging with security in mind isn't top of mind. And the recommendation I make here is pick a model. I am really a big fan of MITRE ATT&CK. I've been using this as a model for having strategic discussions with C-suite executives for almost 10 years. Oh, well, it hasn't about 10 years, for about 5 years now. And it's great because, one, it's an ontology of all of this attack techniques that bad guys are going to have to use some of these to execute an attack. They can change what their attack looks like, but they have to use some of these behaviors. One of the cool things about attack is that for each sub-technique, it's annotated with the data sources and specifically the data elements that are needed to detect that use case. So if you're building an application and you start doing your threat modeling and think about how is somebody going to attack my application, if they're able to compromise an account, if they're able to overflow a buffer, which is going to happen. I don't care how good you think you are as an application developer, you're going to have bugs. Some of those bugs are going to have security relevant consequences. And what you want to think about is when those things happen, what telemetry are you going to be sending off to your SIEM so that your SOC team is going to be able to use that information to either detect in real time that something happened and then contain it, or do the forensic work afterward should there be a breach. And so they're annotated with the data components. Look through them. When you do your threat modeling, think, okay, is somebody going to use this function to escalate privileges? Read through escalate privileges, look for the data components that are required, and think about, can you add the logs that would support that? Because if the logs are there, it makes the use case detectable. If the logs aren't there, you can't detect it. Then generate logs that satisfy those prerequisites. Use a common format. Pretty much every SIEM supports syslog seamlessly. Most of them support JSON logs seamlessly. Windows event logs can be converted to those formats using things like WinLog Beat or NXLog Agent, but make sure you're logging in a format that can be easily consumed, and then treat them as an interface, because the very hardest thing about running any sort of large-scale monitoring and detection operation is maintaining all of your parsers. When running an MSSP, we supported somewhere around 500 individual different devices. When you factor in all the different versions we had to support over time, it ended up being over 7,000 different parsers. And we had a whole team that their whole job was figure out when one of our parsers broke because there was an update, and then update your code. So if you treat your logs as an interface, and that it's going to be used by somebody and it has to be consistent, if you're going to make a change, you need to update the interface version. Make sure you communicate it to the people that need to know that there's a version. And if you treat it that way, it makes the whole process of maintaining and managing parsing much easier. And then leverage the SIEM data model. So I have used all three of the ones I've listed before. Google with Chronicle, we support the universal data model. I've used Elastic Common Schema. Lots of people use Splunk's SIEM model. The idea here is make sure that your logs have the data in them that supports this meta model, because it's way easier. Most enterprises have multiple different brands of firewalls, different IDSs. When you acquire somebody or you merge companies, you're going to have a disjoint in your tech stack, and if you're mapping those logs to a common model, you can build your detections to that model. And then when you change which firewall you're supporting at your perimeter, you don't have to worry about updating your detection use cases. It makes things very much easier for maintainability. Next. There we go. Here's just some ideas of what you should include in a good log. If you've been developing software for any length of time, some of this shouldn't be much of a surprise. But you really want to have the who, what, when, where, and why. The how usually comes from the forensic investigation after the fact. The most important thing for me is make sure you have a timestamp. And if you're not going to make it in the UTC, include the time zone. You would not believe how much time I've spent trying to resolve issues with timestamps. If time wasn't a factor of computing, it would be almost trivial to write software, but I spent way too much time with timestamps. You need to know what happened. So was it a process or start-stop event? Was there a new network connection? Was it a failed login attempt, a successful login attempt? You need to know that. You need to know where it happened, not just the machine that it occurred on, but where the connection occurred from. IP addresses are terrible for detection. One stat we developed over time is that the shelf life for an IP address indicator of compromise is roughly 8 hours. If you don't detect something within 8 hours of learning of it, it's basically useless. And also with DHCP leases being so low in many enterprises these days, the internal IP address is only useful for usually 8 to 12 hours. And so you need to have the host name. That makes it much easier for the SOC to associate those two. And a cloud-specific addressing. I'm not a cloud architect by any stretch. But they all do have some unique addressing schemes for identifying assets. Make sure that's included if you can. Who did it? That's important. You want to know which accounts are affected. Is it an admin account? Is it a system account? Is it an end user? That's important in understanding the severity. How is it performed? I was doing IR and software development before the cloud existed. And so we were focused on, is it a network session? Is it an interactive login session? Nowadays, it was an API. Which API? Is it in our cloud, some other cloud? Is it some other on-premise? That's all really important to know. And then why was it performed? So if you know, this may not be something you know at the time that you're writing the software, why an action was performed, but if you know, include it. It gives a clue if this is a normal event or it's caused by some other environmental factor. And then breadcrumbs. So one of the hardest thing is correlating things. You know, you can do it by IP address, you can do it by host name, you can do it by username, but if you have information readily available and you can include it in a log event without affecting performance, please include it. You never know what's going to be useful in tying those breadcrumbs together. One of the sort of tenets of security investigations is you never know what data you're going to need until you need it and you don't have it. So it's best to log things that are readily available. I wouldn't sacrifice performance by gathering a bunch of context when you're in the middle of some sort of a high-performance computing operation. But if it's there, use it. And if you can do these things in your logs, it'll make it much more usable by the SOC for both real-time detection and I'll talk a little bit more about specifically those detections. So when you log, think about the kinds of analytics that are going to be performed. Most detections in SOCs today are still done using indicators of compromise. These are basic things like source IP address, domains, full URLs, hashes. They're really, really good at detecting known threats. You know, you're reading Intel reports, it's got a hash in it. You get the most recent DHS report, it's got hashes or IPs in it. You can throw them in. You can basically detect things in real time. Most SOCs I've worked in, you can detect an IOC in a fraction of a second. For correlation rules, this is where you're taking multiple events, correlating them into try and take sort of non-primary indicators of an attack and identify an attack with them. That takes more data than an IOC. An IOC you can detect with one log. With correlation rules, you're going to need a collection, 5, 10, 50, 100. It's usually in the order of somewhere between 10 and 1,000. So think about if you're building software and you do your threat model and you think, you know, the type of attack that's going to happen, I'm going to need to know when 10 login failures occur and one's successful. Make sure you're logging enough things so that you can meet the data needs of that. And also, factor that into your budget. Cloud is a consumption-based business, so everything you do in the cloud costs you money. So you want to make sure you budget for the data that you need to include as well. Behavior rules are fun. It sort of threads the needle between IOCs, which are really good for known attacks, and machine learning, which are better for unknown attacks, potentially unknown attacks, but aren't good for known attacks. Behavior rules are really what MITRE ATT&CK's built around. If you can identify behaviors and correlate those behaviors into patterns, those allow you to potentially identify previously unknown attack techniques or attack malware or living off the land and require relatively little data. You can detect a behavior in as little as one log. Generally, they require 2 or 3. And they're very powerful, but you have to be able to log all the different types of events. And if you're thinking about it from a software architecture perspective, the code may be getting, for the different types of events that the events might be occurring in, could be in different components, different services. If you're in a multi-cloud implementation, they could be across clouds. So you want to make sure you have a way of bringing all that into one cloud or one area, and so that they can be correlated. That's really important. For statistical modeling and ML, these are tough because for statistics, you need to usually compute a baseline. You want to compute means and standard deviations. You're going to need more data, so you got to budget for that. You got to log things in volume. It's going to be very verbose. For machine learning, generally to train a model, you need hundreds of thousands to millions of labeled records. So this may not even be doable from a software architecture design if you're just thinking about logging, but know that if your SecOps team is saying we need to support these new ML models, you may have to either say no and explain why, because there's no way you can predict the logs you'll have to generate to support some sort of ML model, Or you're going to have to factor that into a larger development effort because it can be substantial. You need to both generate logs, but also generate labeled exemplars. So think about the kinds of detections that would happen through your threat modeling and architect your software in mind. I would imagine it's way easier to detect the top 3 on this list than the bottom 2, but that gives you ammunition to push back when you're being asked to do something that may not be reasonable. Make your apps orchestration friendly. So raise your hand if you have a SOAR implemented in your enterprise. Okay, that's about 6. That number's way up from last time I asked this question last year. SOAR is becoming the way that automation happens. The biggest issue that SOCs are facing right now is volume. Data volumes are growing exponentially. Alert volumes are growing exponentially. If you heard in the keynotes this morning, the problem continues to grow at a near exponential rate. You couple that with the fact that we're at a 600,000 person deficit in the job market for security right now. It's predicted to be 3.2 million by 2025. I don't see this ever getting better. It's going to get worse exponentially. So if you're trying to solve security problems with people, never going to happen. If you're running a for-profit service like I used to, there's no way you can do that at a profit unless you start automating everything. And SOAR is the way that it's kind of democratizing automation throughout most security operations centers. Most SecOps teams do not have software engineers on staff. And so the way to make this happen is these codeless frameworks and platforms that handle all the hard stuff. They handle scalability, they handle integration and error recovery. But if you're developing, what they're going to be using this for is a couple things. One is they're going to want to, when there's an incident or a potential incident, they're going to run playbooks. They're going to gather context about what's happening. If they don't have it, if they just get an event based on an IOC, they're going to go figure out, if they can, what process made that network connection, what user was that process running under, what machine was it on, are there any other machines that have similar process or similar programs? They can check by hash. And then they're going to potentially do things like update the SIM detection rule set. More importantly, if there's an event where they're going to take automated action, there's going to be playbooks that will do things like lock out user accounts, force password resets, shut down VMs, shut down services potentially. Hopefully that's agreed upon between DevOps and SecOps. It doesn't always happen. But at the end of the day, they're going to do all these things. So you want to make sure that you're adding the hooks in. Most of these integrations are done through REST APIs. And fortunately, you're probably doing a lot of this stuff to support your SRE team, unless you really hate your SRE team. So the things you want to think about adding are interrogation capabilities. So things like who's logged in right now, how many users are logged in, what machines are connecting, are there any connections that are not associated with login accounts, what files are open, things that you might also use for debugging. But on interrogation, a SOAR playbook, we may want to use this to build context. You're going to want to add in hooks to suspend or kill certain parts of an application because it could be that you get, say, a vulnerability exploited. There's a process tree created by an attacker, and you may want to be able to kill the whole thing. So if you can add that hook in there to do it through the application, you want to do that. Things like initiating a password reset. This is really important for like cloud native services. I get these a lot. In fact, I'm a big Steam user, video game guy. Somebody from Russia keeps getting a hold of my password on the regular. So Steam will send me, part of their process is to send me a password reset initiation whenever that happens, and then I have to go through the whole process and do it. You want to make sure you add those hooks in so that you don't have to have a person doing that manual action all the time. And then things like block lists and restarting containers. So design with orchestration in mind because it will make it much easier for you to integrate with the SOC processes. Then lastly, on continuous feedback, there's really no magic here. The idea here is just remove silos. There's way too much friction I'm seeing in the world today between DevOps and SecOps. Either the security team is getting in the way of deploying things. I was listening to the panel on adversarial intent earlier. A lot of the talk was around how security controls are preventing deployment. You're trying to deploy an application, deploy an update. and the security team gets in the way. You need to be breaking down those silos, working together, share metrics, share dashboards. That'll help you gain influence throughout the rest of your organization. Participate, your DevOps team should be participating in SecOps postmortems, should be participating in incident investigations. Ask them, what kinds of things are you doing in terms of automation detection that we can help build in, because breaking down those silos will really help you with the continuous feedback, because we're all, shared fate, Wade talked about earlier, we're all in this together, it's one team, one fight. The more we can break down those barriers, the better. And if we do this right, all right, if you ever had the question, does converting from Google Slides to PowerPoint preserve animations? The answer is yes.
Yep, it works.
I was worried about this because we didn't test it. All right, so if you do DNR right, so you're taking some of those recommendations and you're helping your DNR team. One of their big goals is to shift left in terms of detection. If you look at either the MITRE ATT&CK framework columns, or you look at, say, the Mandiant attacker lifecycle, the goal is to start detecting things earlier in the attacker methodology. And so doing this kind of stuff will help your SOC do that. If they're doing their jobs right, they're going to generate net new intel. So they'll do, they may find an attack, they'll generate additional IOCs. That's going to go back to your intel team. They're also going to learn about how to implement better protective controls. So the detection and response informs all the foundational controls that Wade was talking about. They'll know because they detected something or they didn't. They'll know from the attack that you could have done something with the configuration or a control or a block list that would have prevented a similar attack in the future. And then intel goes backwards to help prevent the attack from happening in the first place. That work will also inform your patch and vulnerability management. I'm no expert in patch or vuln management by any stretch, but what I hear from my customers a lot is that they're overwhelmed with vulnerabilities. There's just way too many, need help prioritizing them. The output from the SOC is going to help inform which ones need to be prioritized. And then getting back to how that benefits the developers, ultimately, if those other three areas don't fix the problem, what needs to happen then is requirements need to be sent back to the DevOps team that don't prevent the agility of the business, because ultimately security's job is to enable the business to achieve its goals in a secure way, but give those requirements to the engineering team so that product management or whoever's in charge of making these decisions about which things get prioritized can factor that in. And if you do all that, if you can do all this from end to end, you get a loop where you're continuously getting better from DNR all the way through building more secure software. And then hand it over to you.
Awesome. So thank you, Steve. So thank you all for joining. So what are some things you can do to dive in further and make this actionable? Visit on cloud.google.com where you can see our Google Cloud Security Resilience Framework that I mentioned and deeper guidance around our security foundation and security foundation solutions around all the cloud adoption journeys, including application modernization. Look into our software delivery shield, which is a exciting new solution that we just announced last week at Google Cloud Next, which is our secure software supply chain solution that ties together a lot of the technology I talked about, including additional capabilities such as our cloud workstations, which is a secure IDE environment that's hosted in Google Cloud that takes advantage of all the cloud security capabilities. And then dive in further into the autonomic security operations that Steve has been talking about, which is our philosophy and approach to transforming and modernizing the security operations program. And I know we're right at time. Yeah.
Sorry, just to add on to that. I know we're in DC. If you work in the public sector, we also have a public sector ASO white paper that is designed to help you figure out how to meet all the requirements of all the new executive orders using the ASO approach.
All right. Awesome. So thank you all. I know we're between, we're the last session, so between us and drinks. But feel free to reach out with other questions. And thank you.
Thank you all.